again, this diagram and definition are cut out of chapter 15. So this information on chapter 15 as well as the cylindrical coordinates. So, okay, so far we've talked about two types of mappings or coordinate systems. One is the rectangular coordinate system, and that system is like the type of system where you're telling somebody to go so many blocks east, and then so many blocks north, and then go up near, okay? I mean, that's how you're finding points in the rectangular system. You're going so many spaces X, so many spaces Y, and then so many spaces up and down. And you can get anywhere in the 3D universe with that system. The cylindrical system has somebody stand at the origin, point themselves down the positive x-axis, and then you rotate a certain angle. Once you're pointed in the right direction, so picture like having a compass and you're supposed to, walk a certain angle, then you walk a certain distance out. That's the radius that you're moving in the xy plane. And then once you've moved the right distance out from the origin, then you go up or down according to z. That's cylindrical. Spherical is just emanating out from the origin. You're at the origin and you just move out from the origin, like a particle blasting out from the origin. You can maybe picture a laser beam centered at the origin, and the beam can get moved anywhere, and if you had a very directed laser beam, you can kind of see the end point of it. So, how we explain where a point is using spherical is we explain the angle rotated from the positive x-axis, just like in cylindrical. Okay, so theta is the same angle as in cylindrical. It's measured from the positive x-axis. You stay in the xy plane. Rho, that it looks like a P, but it's the Greek letter rho. Rho is a radius, but instead of using R, because R already got used in the cylindrical coordinate system, and rho is not measuring the same thing as R, rho is a radius, but instead of staying in the xy plane, like you do with R in cylindrical, you're emanating out from the origin. So it's the distance from the origin to straight out in space. And then phi is another angle, and it's measured from positive z, which that out of the three things, that's probably the most unintuitive to most students, it seems, that people want to measure from the xy plane, but you're not measuring phi from the xy plane, you're measuring phi from positive z. So it's actually the complement of what angle you would get if you measured from the xy plane. So rho squared is what we discussed the other day, actually, because at the very top of your paper, at the very beginning of your packet, is the distance formula. Well, this is the same distance formula, because I'm measuring from the origin. So x minus 0 squared plus y minus 0 squared plus z minus 0 squared is equal to d squared, but we're calling d rho right now, okay? So that's where you get rho. And then there's a relationship between x and y and z. So x, y, and z are the same rectangular x, y, and z. And actually, on Tuesday, I think we didn't talk about the connection between x and y and z and cylindrical. So I'll backtrack after I'm going to continue our discussion about spherical right now, but as I'm talking about this, I'm remembering that we didn't talk about the connection between x, y, and z in cylindrical. So rectangular x is equivalent to rho times sine of phi times cosine of theta. Rectangular y is equivalent to rho times sine of phi times sine of theta. And z is equivalent to rho times cosine of phi. Let's talk about z first, because it's kind of the easiest to draw a picture for. Okay, so rho is this distance here. If I find the shortest distance from this point to z, I'm actually forming a right triangle. Your perpendicular distance is always your shortest distance. So if I want to go from a point to the z-axis and I go the shortest distance, you're always going to be forming a right angle. So cosine is equal to adjacent over hypotenuse, right? So for this triangle, the adjacent side to phi is whatever z is. And the hypotenuse of the right triangle is what rho is. So rho times cosine of phi equals z. Okay, I mean, I'm pointing this out because these are not just made up definitions. I mean, there's logical trig behind where all this stuff comes from, okay? So that was kind of the easiest one to draw a picture of. X and Y involve two different right triangles, kind of like the actual distance formula in 3D ends up requiring two different triangles. I'm glancing at the way this is oriented to figure out if I were going to draw a picture for you, what the most efficient picture would be.